Hello and welcome back to Physics for the 21st Century. My name is Greg Perugini, and today we're going to be talking about work. So that is our topic. Let's get on with it. Work is a little bit different than everyday parlance. When we talk in physics about work, we're talking about movement. If I'm pressing against something, if it isn't moving, I can press against it all day, all night, and I'm not doing any work. Work is force times a distance. And if it's at an angle, if I'm pressing down at an angle, I have to take into account cosine of that angle. The unit is in joules. If we're plotting force for a given distance, work is the area under the force curve. So we have a distance. Well, let's do a little bit of an example here. So you write down what we just talked about. Work equal force times the distance, and I'll put cosine of the angle here, and you'll see what I mean in just a second. Because if I'm pressing down and we think of force as a vector, well, some of that force obviously is down, and some of that force is actually moving the object. Let's say I'm pressing on this box to get it to move, and I'm pressing at an angle, let's say of 40 degrees. If I'm pressing with a force of 60 newtons, and I am moving this box a total distance of let's say 12 meters, I can calculate how much work I'm doing. Work is equal to the force 60 times the distance 12 times cosine of 40. The cosine being, of course, is that portion of the force vector that is actually making the movement happen. If you did this example here, you would get 550 joules. That's work in a nutshell. Now, as you see here, we're moving at a distance from A to B and with a force. I could, instead of be pushing, I could actually be pulling on this as well. And again, it's force times cosine of the angle, the force necessary to move that block. Force times distance giving me work. Now, I mentioned that if we plot this, I mentioned in the first slide that it is the area under the force curve. Well, we're not going to work with curve just yet. Consider this a force line. This is force for a particular displacement. Let's say, well, I'll make this larger in a second. But it's the area under the force line here that is the work. And let's do an example. Let's say I am doing this force, and then my force goes down. This is in newtons. This is in meters. And as I said, it's the area under the curve. So, what is the work done from 0 to 4 meters? If I'm up here at 6, what is this area? Well, obviously it's just a block here. The work done from 0 to 6, or excuse me, 0 to 4 meters, starting at 6 and staying constant at 6 for those 4 meters. Well, it's 6 times 4, 24 joules. What about from 0 to 9 meters? Well, we still have this block here, right? But then we have this block here. Still have that 6 times 4. But I also have from 4 to 9. Okay. And if we think of this, this is 5. Let's use another color here so you can see a little better. What is this block here if we were doing that full thing? This is a 6 by 5 block. And this triangle then is half of that. So it's 1/2 times 5 by 6, and I add that to this original portion. So if I'm going here for 4 seconds at 6 newtons, then I drop down at a steady rate for the last 5 meters. I add both of these up, and you can do that yourself. (39 joules). So from 0 to 4 meters, it's pretty easy. It's this little box here, and it's 24 joules. If I'm doing that plus from 4 to 9, an additional 5 meters with a diminishing force, I would add that diminishing force to it, and it is 39 joules. Okay, so in conclusion, remember, work needs movement. If I am not moving an object, I can be pressing on it all day and all night, and I'm not doing any work. Practice problems before you do the assessment. Be very clear on how to do work and how to calculate work. And remember the units. Also, do significant figures properly. And good luck!